was not so bad. But this is the first time you saw it, kind of tough. It's usually tough for most people because this is where you have to be able to factor, right? So factoring is important, and then there's different rules for addition, subtraction, multiplication, division. So equivalent forms was the first thing we talked about in rational expressions, writing something in equivalent forms. So here, is there anything we can factor out of this, the top or the bottom? The bottom we can factor out 2. So we could write it out as 8a squared over 2 times, what's left over in the brackets? A minus 3. Okay, now what can we reduce? The 8 and the 2. We can divide the 8 and 2 both by 2. So this will be a 4, and this is going to be a 1. Can we reduce these a's? No, right? This a minus 3 is attached. It has to only reduce with identical a minus 3. Can't reduce it. So an equivalent form would be a squared, 4a squared, over a minus 3. Now, we also covered something else. No. If it was like 4a squared minus 9, that would be a difference of squares. Okay? It's a perfect square. That's for sure. Okay. Another thing we talked about is at non-permissible values. What are NPVs? What it can't, and so why is there NPVs? You cannot do what with 0? Divide. You cannot divide. It can't be on the bottom. So cannot divide by 0. So therefore, our NPVs are what would make our denominator 0. Scared me. What would make the denominator equal to 0? So on this one, is there a non-permissible value? Yes. A can't be equal to what? 3. Yeah, because a minus 3 can't be equal to 0. So if we add 3 to the other side, we get a can't be equal to 3. Okay. So what would make our denominator 0 is our non-permissible value. What page are we on? 33. All right, so let's simplify this guy. The numerator, what do you notice about the numerator? Can we factor it? The top. Numerator's top. It's a difference of squares, because we can square root both of those, 2 terms separated by a minus. So when we have a difference of squares, we take the square root of each number. So square root of 36y squared is what? 6y. So 6y is going to go here, and 6y here. Square root of 1. So you're going to have 1, and a plus 1, and a minus 1. They have opposite signs, and that's why the middle term cancels out. And it's left with 2 terms when you expand it. Okay, what can you factor out of the bottom? 2y. So we're going to divide both by 2y. 12y squared divided by 2y. 6y. 2y divided by 2y. Anything divided by itself? 1 is 1, minus 1. So that's a common mistake, right? We factored out 2y. So the top was a difference of squares. The bottom, we could, there was a common factor of 2y. So we factored out the 2y. All right, will anything reduce now? 6y minus 1. And so our solution would be 6y plus 1 divided by 2y. What are my NPVs? Things that y can't be equal to. 0, because 2 times 0 would be 0. And then how do we get this guy? Remember, we have to do the ones that before cancellation. So we look at NPVs before cancellation. Okay, so if 6y minus 1 can't be equal to 0, what's our first step? Add 1, and then, so 6y can't be equal to 1, now what? Well, I'm just solving for y here. So this bottom can't be equal to 0. So the NPV is, remember the opposite sign, second over first? So this would be 1, 6. 0 and 1, 6. 0 and 1, 6. Switch the sign, second over first, right? Or you can just set it equal to 0 and solve. So what would make that 0? Okay. And then 2y, that can't equal to 0. And 0 divided by 2 is still 0. So that's why this is just 0. Cool? Beans?
Yeah.
Okay, I want you to try and factor this guy as much as you possibly can. It's not that hard. Factor the amount on the top. Difference of squares. So what does this become when factored? M plus 2, M minus. We notice it's a difference of squares because of two terms, both perfect squares and separated by a minus. Times, okay, 12. Factor 12 out and we get M minus 2 over 16M. Okay, what can reduce out now? Okay, the M's. What else? M's, remember? What else? One on the top, one on the bottom. It could be up and down, as long as one's on the numerator, one's on the denominator. It's the only way it can cancel. Up, down. Has to be one up, one down. Yeah, and it could be vertical or across. So what else can cancel? M minus 2's. What else? M plus 2. So what are we left with? 12 divided by 16, or that we can divide both those by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. Now, at non-permissible values, we still have those. M can't be equal to plus or minus 2 and 0. So that would be my solution. Okay, division. If you have two fractions being divided, shh, guys, how do we divide fractions? You flip which one? The second. So you multiply by the reciprocal. The reciprocal. Yeah. And then we can go straight across and reduce across if you want. So 5 over 6. So same idea here. We want to change this. Guys, there's way too much talking. Leah. Jesse. So the first thing we want to do is get rid of the division by changing it to multiplication. So we're going to flip the second guy. Now, if we want, we can multiply straight across and then reduce, or we can start reducing now. Multiply? Sure. Reduce first. Okay. I mean, really they're the same. No, so we just change them to multiplication by flipping the second. Okay. So I'm going to go straight across to show you can reduce after, especially when we're dealing with monomial times monomial. So what's 20 times 6? 120. What is x squared times x squared? X to the 4 all over 15 times 4, 60. What's x cubed times x? X cubed times an x to the 4. And we'll leave the other in factored form because you want to leave it in factored form. So what can reduce out? It's a little simpler to see now. Yeah, because we add the powers. Yeah. Yes, it's x cubed times x, because x cubed is this times an x to the 4. You add your x cubed times x is x to the 4. You add the exponents when you multiply. Oh, no, x cubed times x. No, it's not plus. We can't add, but you're adding the powers. You can't add these together. When you multiply, same basis. Okay, so x to the 4s can cancel. 120 divided by 60, what will that equal? 2 over 1. You can reduce that to 2 over 1. So we're left with 2 divided by x minus 1. X can't be equal to plus 1 or 0. Okay. Now, addition and subtraction. When we add fractions, what do you need? You need a common denominator. So this would be 3 out of 6 plus 2 out of 6. Okay, ladies, you need to split up. You two, split up. You're talking, and I can't teach over top of it. Stacy, can you please move? Your giggling is way too distracting for my own teach. I can't even teach over it. Find somewhere around. There's many spots. Okay, so does this have a common denominator? Yeah. So if it has a common denominator, we can just write everything on one under one denominator. So 5x plus 1 plus a 3x minus 1 all over x minus 1. Okay. So can we add like terms now? Yeah, what is this going to equal? Just 8x, because what happens with the 1s? Cancel out. Non-permissible value? What? That was easy. Yeah, because there was a common denominator already. Now what if it's not yet a common denominator? We're going to make it one. Well, we want to make it the same. So looking at the bottoms here, the x plus 1 is missing this denominator of a 3x. So what do? We're going to multiply top and bottom by 3 and x, because this guy's missing the 3x. We want to make the denominators the same. So basically this guy, we're going to make them each have both denominators together. Minus 2 over 3x times, so what is this guy missing on the bottom? X plus 1. So multiply top and bottom by x plus 1. Because we want a common denominator. The x plus 1, because x plus 1 is different than just x. So you have to keep it together. They're two different things. Okay, so now you could rewrite this as 3 times 3x is 9x all over. I'll put this in front. 3x times x plus 1 minus. Do you want to expand this right now? Okay. I'll just write it like this here. We'll take it one step at a time. So now they have common denominators. When they have common denominators, what can we do? Yeah? We could, but some people it sounded overwhelmed. So I was just going to take it in multiple steps. Okay, so we can write it all under one denominator now that we have a common denominator. So we can write 9x minus 2 times x plus 1 all in the same numerator. So simplifying the top, what do we have to do still? Distribute. So 9x minus 2x minus 2, or 7x minus 2. And non-permissible value? Tough. Yeah, adding and subtracting was the toughest part. 0 and negative 1. Okay. So basically, if you look at the denominators, if they're different, then you're basically multiplying top and bottom by the other guy, whatever they're missing. Okay. Yeah. So we're at equations now. How much is left? One more question. Yeah, we do. Yeah, we do. This is so blurry. Sorry. Drives me crazy. Okay. Okay, now solving equations, there's a few ways we can solve equations. I'm going to show you a couple of them. Okay? You need to be able to solve it algebraically. I'm going to show you how to solve it algebraically. And the second way is we can solve it graphically. Okay? Now graphically, it's kind of hard because you'll see when we actually graph it. But we can solve them graphically, but they can be difficult to solve graphically. So here, if you're solving this an equation, we want to get all the denominators the same. Because if it's an equality statement and the denominators are the same, then the numerators are also the same. Okay, so here, what is this guy missing? An x plus 1. So we're going to multiply top and bottom by x plus 1. Okay, next guy. What is he missing? An x. So we're going to multiply top and bottom by x. Okay, 6x squared, yeah. And this guy, who is he missing from his denominator? Both of them, right? So we're going to multiply top and bottom by x times x plus 1. Do they all have the same denominator now? Yes, because it's an equality statement and everyone has the same denominator now, we can therefore set just the numerators equal to each other. So therefore 4 times x plus 1 plus 6x squared equals 6x times x plus 1. There's a few ways to solve these. I'm going to show you one way, and then I'll show you another way after. Okay, because the denominators are all equal, we can set this statement above all equal. Okay, I'll show you another way after. Okay, so then that gives us, let's expand this and now solve. 4 times x, 4x plus 4 times 1, 4 plus x squared equals 6x squared plus 6x. We need, whenever you have a square, let's get all the squares on one side. Okay, so if I want to bring, say, this 6x squared to this side, what are we going to do? We want to bring this guy to this side. How do I do it? Minus. So what happens with our 6x squareds? Turns into actually, they cancel right out. 0. So now we have 4x plus 4 equals 6x. Now what? Subtract 4x. we have 4 equals 2x, so x is 2. Okay, now with your solutions, you always have to check that it's not a non-permissible value. So going back to the original, was it a non-permissible value? No, so that's our solution. Now, really quickly, another way we could have solved this and it's called extraneous. It's an extraneous solution. Okay? And that might show up. Then there might be two solutions, 1, 3, 1, negative 1, right? Or there'd be no solution if pardon me? You just have to look at your solutions and see if any of them are non-permissibles. If they are, then there's no solution. They're extraneous values. Okay? Two more ways to show you how to do this. Another way is to add the two together. And then we can cross multiply. So here, I'm just going to add those two together so that we have a ratio equaling a ratio. So here, this is missing x plus 1. And this guy's missing an x. Oops, plus. So we're just going to add these two together first to make it a ratio equals a ratio. So now we have a common denominator, so we can put it over x times x plus 1. Okay, so just dealing with our addition like we do with any addition. So add those ratios together that are being added. What happens is 4x plus 4 plus 6x squared. We expand it. Where x times x plus 1 equals 6 over 1. Whenever we have a fraction equals a fraction, we can cross multiply. Okay, so we did cover that. So then 1 times this, which is just anything times itself, equals 6 times x plus 1. Okay, so it is a way to solve it, and then you still get the same answer because you'll expand this. See how this is the same as that right there? Okay, because in rational expressions, sometimes they like to find the error. So you have to understand the different ways to solve it. Okay, and then the x squareds will still cancel, and we get 2 equals x. The third way solving them is graphically. Okay, now in your graphing calculator, if I wanted to solve this graphically, we'd have to type in y equals the left side, so 4 over x, plus, how would I type in 6x over x plus 1? What would you need? Brackets, x plus 1. And then y2 is 6, because we're looking for an intersection point. Now, one thing you need to know about rational expressions, they look really funny. I think I'm in trig mode. 1 second. Zoom 6. There we go. See how it does that? Because it's a rational expression, there's non-permissible values. And so these are called asymptotes, and those occur where there's NPVs. So that's another way you can get your NPVs. It's the asymptotes. And then second, Calc 5, we're looking for our intersection point, right about there. And there it is, x equals 2. Okay, so that's a good way to check your work.
What can I see y equals?
Here. Okay. All right, so you have time to work on the practice. We might spend some more time on rational expressions tomorrow, but I'll give you some time. Yeah. Nice, it's working today.